Now watch this, all right? Everybody looking around you, because watch this, I'm gonna ask you a question. Raise your hand if you did these problems. Oh, look at that. 3 people in the whole entire class did the problems. All right, so on the video, you wonder why they didn't make A's, everybody on the test. Come on, guys, okay? Come on, I asked you to do what, 7 problems? And all you had to do was say discrete or continuous, and you're like, nah, I don't have time.
I totally forgot to do those.
Okay. I don't know. You weren't here that day. Okay, so here we go. I want you to, we're gonna do them in class, okay? Now listen to me. Are you going to have some problems like this on the test?
Yes.
Are there problems like this on the chapter review or the chapter test?
Maybe. No.
No, there aren't. This is one of those extensions, okay? See, it's like this. See where it says extension? It's in between chapters, all right? So it's like something extra, so they're not on the chapter reviews and the chapter tests. So these are the only problems that you'll have, all right? So most of you took a picture that day, so you'll have that picture. You might want to write the answers down. So number 2, here's number 2. They give me the equation f of x is equal to 0.5x minus 4, and my domain is -4, -2, 0, 2, and 4. Discrete or continuous? Tell me why. Okay, yeah, it's just got these integers, -4, -2, 0, 2, and 4. Now they don't have to be integers, do they? But it's just got these specific points. It's not anything in between. So what am I talking about? What's it gonna have to be continuous? It's gonna have to be an inequality. Very good. Which leads me to number 3, where it says y is equal to -3x plus 9, and my domain is any x less than 5. What is that? Yeah, that's continuous, guys, because it's not at 5, but it starts at 5, and then it's at 4.9, 4.8, 4.7, 4.6. That's the way my brain thinks about it, okay? It's all those in between. It's everything. It's not 5, 4, 3, 2, 1 specific ones, okay? What about number 4? Discrete or continuous? Why? It has an inequality. Y'all, it is that simple. When they just throw it out there like this, if it is specific, if your domain is these specific numbers, okay, then that's discrete. Because this x will have one y, this x will have a y, this x will have a y, and it'll just be points, all right? This is going to be a whole bunch of points that are connected together. All right, so these are real life application problems. The first one, Amanda walks at an average speed of 3.5 miles per hour. The function d of x gives the distance in miles. Amanda walks in x hours. So the x value is what you're looking at. Notice that every time up here they gave me the domain. And the domain was the one that told me if it was discrete or continuous. Okay? So obviously I'm looking at x hours. All right? Time. Discrete or continuous?
No, it's continuous.
Why?
Because it keeps going.
Yeah, you could have 1 hour, or you could have 1.1 hours, 1.2 hours, 1.3 hours. You can have that time in between the hours, okay? It's not just like 1 hour or 2 hours. I can walk in between. All right, look at number 6. A token to ride a subway costs $1.25. The function s of x gives the cost of riding the subway x times. Remember that this is what you're looking at, okay? Continuous or discrete? Very good. So you're paying tokens to ride the subway. That's how many times you ride it. You give a token for each time, okay? So you can ride it 1 time or 2 times or 3 times, all right? And so that is discrete. Here's number 7. A family has 3 gallons of milk delivered every Thursday. The function m of x gives the total amount of milk that is delivered to the family after x weeks.
It's discrete.
Why is this one discrete? Because the kids last period, the kids were like going, no, that's not discrete, that's continuous.
Well,
because you could do it in between. Can you do it in between?
Yeah.
It says it's delivered
But
every
it's
Thursday.
only
Oh,
Thursday.
there you go. A said it says it's delivered every Thursday. So it's this Thursday or it's next Thursday or the next, do you see what I'm saying? That's not in between, so that is discrete. Very good. Okay, number 8 says steel cable that is 3/8 of an inch in diameter weighs 0.24 pounds per foot. The function W of X gives the weight of X feet of steel cable. So X is the number of feet of steel cable. Discrete or continuous?
Continuous.
Yeah, continuous, because you can buy 1 foot or 1.1 foot or 1.2, 1.3. Okay, that's the way my brain kind of thinks about it. It's kind of making it an inequality without using an inequality sign. I can do the in-betweens. Okay, number 9. On a number line, the sign distance from a number A to a number B is given by this formula, B minus A. The function d of x gives the sign distance from 3 to any number x.
Continue.
Yes, any number x. So it could be 3.1, 3.2, 3.3, 3.4, 4, 4.1, 4.2. Okay, so any number and those ones in between. All right, everybody got it? Okay, so that will be on your test Friday, next class. Your worksheet is due, and I think, is this where we were? No, I know that's not. Is this where we were on your worksheet, on your notes? Okay, so we are a little bit behind, but not too bad. So, all right. Wow, no, here it is. I was like, I'm having to make stuff up now, but I'm not.
Wait, we're looking at the screen?
So we talked about we started talking about standard form, okay? So standard form is when AX plus BY is equal to C is standard form. The X's and the Y's are on the left, the X comes first, the Y comes second. Our constant or our plane number will be on the right. And A, B, and C must be integers, and that means they can't be a fraction and they can't be a decimal. All right, so here's my first problem I want us to look at. 3y minus 2 equals 7x. 3y minus 2 equals 7x. We're going to put it in standard form, okay? So in standard form, who goes on the left? Yeah, the 7x, and he's on the right, so when I move him to the left, what does he become? Negative 7x. My 3y is already on the left, so that's negative 7x what?
Plus.
Yeah, he's a positive 3y. Equals, and my plane number or my constant goes on the right. So this negative 2, you have to move over here to the right, and he becomes what? Positive 2. All right, so this is standard form right here. Okay, now here's my only warning. My only warning is that back 900 years ago when I was in school, we were not allowed to make the coefficient of the x, the a couldn't be negative. All right, and then sometime after that, the books changed and they said, oh, okay, we'll let it be negative. But when they give a standardized test, generally, they would not put an answer like this on a standardized test. They're still going back to the old school rules where they don't want that to be negative. So could you tell me what this equation would look like if I didn't want this guy to be negative?
7x minus 3y equals -2.
Very good. So really all you're doing is you can either say I'm multiplying or you can say I'm dividing because it's all the same thing. Everything by -1, okay? And so all it does is changes everybody's sign. So I just want you to be aware, I'm okay with this answer right here, all right? Not a big deal, but on a standardized test like your SAT test or your ACT, or even if we took, like one year we took an end of course algebra 2 test, okay? They would most likely not going to have a standard form with that first term as negative. They just don't like it, they think it doesn't look good, and so they just change everybody's sign. These two, if you graphed both of these lines, they would both be the exact same thing. Anybody got a question? Okay, so here's the next problem. The next problem looks like this. 2/3 x plus 4y equals 1/2. 2/3 x plus 4y equals 1/2. All right, so they're gonna ask me to put this in standard form. Well, I got my x's on the left and my y's on the left. The x is first and the y is second. My constants are all on the right. What's wrong with him?
This constant is a not integer.
Yeah, the 2/3 and 1/2, those are not integers, okay? You can't have fractions or decimals. So, y'all, which one of these numbers, 2 or 3, makes this a fraction? Which one is the problem? Yeah, the 3, because he's the denominator. 2's not a problem. 2x, that's okay, but this 3 on the bottom, he's a problem, okay? This is why I'm saying it this way, because a lot of times when the kids go, oh, I gotta get rid of this fraction, what do they want to multiply? His what? Reciprocal. But y'all, if you multiply by his reciprocal, yes, this fraction will go away, but you could create one here or here, all right? So we're not gonna multiply by reciprocals. We're gonna multiply by the least common denominator between 2 and 3. The denominators are the problem. That's what we're gonna get rid of. So it's really called the least common multiple, but y'all listen, it is the least common denominator, okay? That's what a least common multiple is. So what would be the least common multiple between 2 and 3? 6. If you remember, we've already done this before. So you start with the biggest number and you list his multiples until you get one that this guy divides into. So 3 times 1 is 3, 2 does not go into it evenly. All right? 3 times 2 is 6, 2 divides into that evenly. So everybody, I don't care if you're a fraction or not, everybody gets multiplied by that number. Okay? Now remember when we did problems like this, remember we said this line means divided by. So we're gonna divide by the bottom number, multiply by the top. Y'all remember when we did that? How many times does 3 go into 6?
2.
What's 2 times 2x? 4x. Okay? So now I've done him, now I'll do this guy. Even though he's not a fraction guy, you have to be fair. Whatever you do to one, you have to do to all of them. All right? What's 6 times 4y?
24.
24y is equal to, okay? And over here you can do one of 2 things. How many times does 2 go into 6?
3.
What's 3 times 1?
3.
Or you can say, hey guys, what's half of 6?
3.
It's all the same. All right, anybody got a question? Okay, the last one, we've done just moving them around. That's what that first one was, okay? We've done getting rid of fractions, and now we're gonna get rid of decimals. So what if my equation looks like this? 4.1x plus 7.28y is equal to 25. Okay, so it said that A, B, and C had to be integers. Is 4.1 an integer? No, and neither is 7.28. 25 is, but these two are not. All right, so what am I gonna do? Does anybody know? Do what? Change them into, that would be the difficult way to do it. I could do that, okay, but that would be really hard to do. Okay, let me ask you this. If I multiplied this guy by 10, what would that do to this decimal point? Yeah, it would move it to the right, wouldn't it? One place, because 10 has 1 0, and then it'd be 41, and he'd be good, right? What would it do to this decimal point? Move it to the right one place. Would I be good? No. Not quite. All right, and he just stays an integer, but he'd be 250. So what do I need to multiply by? 100. Yeah. Y'all, it's actually 10 to some power. And what you do is you look at the numbers and you see who has the most digits behind the decimal point. This guy does. How many digits behind the decimal point? Two of them. So you're gonna have to have 2 zeros. So that means I have to multiply by 100. Y'all, if this guy had had 4 digits behind the decimal point, I would have had to multiply by 10,000, okay? But who gets multiplied by 100? Yeah, everybody does. So when I multiply this guy by 100, people, you just move your decimal point 2 places because of those 2 zeros to the right. 1, 2. And what does the number become? 410 x plus, when I multiply this guy by 100, 2 places to the right, what does he become?
728.
Perfect. Is equal to? Y'all, this guy's decimal point is at the very end. You move it 2 places, you just add 2 zeros. 2,500. All right, anybody got a question? Okay, so that is all of 2.3. Okay, I finished 2.3. I'm fixing to start 2.4. Is 2.4 going to be on your test? No, it is not. Okay, so don't be thinking that what I'm fixing to teach you is going to be on your test. It is not. I'm going to give you some time in class. I suggest I would work a couple of problems from what we're doing today so it sticks in your head, because it's going to be almost a week before we pick it back up again. I'm not going to reteach it, okay? And then we'll move on. So Friday, your worksheet is due. If you're at home, it will be due on Teams on Friday, okay? Not Friday midnight. All right? I'm not playing that game. We're not in Edgenuity. Edgenuity does that. They give you until midnight. I'm not going to give you till midnight, okay? I want it due Friday before school's out. All right? I won't be as specific as your class period, but I will say before school's out. Thank you. Oh, thanks, she's not here. Hey, excuse me, she's not here today. Okay, so let's start on 2.4. I'm going to say this, y'all listen, 2.4. Your next test is going to be over 2.4 through 2.5 and 2.7 through 2.8. What did I do? I skipped 2.6. So here's what's going to happen. I'm going to pull 2.6 out of here. I'm going to pull one type of problem out of 2.7. I think it's example 5 or something. I don't really remember. And then I'm going to pull another extension out, and then I'm going to test you on those 3 things right there. Okay? So that'll be the next test after your one on Friday. No, that'll be your next test after this test, which will be after the one on Friday. So that'll be like your 3rd test. Okay? So we're just going to start 2.4. 2.4 is writing. Oh no, sorry. I knew there was something. I kept thinking there was something I was forgetting. This is what we haven't done in 2.3. All right? Remember I said there was 2 things we hadn't done? But y'all were a little behind, so y'all had 3 things. Okay, so this is pretty easy. An X-intercept and a Y-intercept. Is this on your worksheet?
Yes.
Yes, it is. Okay? If it's on your worksheet and it's in this section, do you think it'll be on your test on Friday? Yes, it will. So tell me what an X-intercept is.
Where it crosses the X
With a Y.
axis.
Yeah, and it's where it crosses where your graph crosses the x-axis, right? Everybody agree with that? Where your graph crosses the x-axis, okay? And then Cole said it's where y is equal to 0. So how do you find it? Well, you make y equal to 0, and then whatever x ends up being, then that is your x-intercept, okay? Your y-intercept is where your graph crosses what?
The Y.
Yeah, the y-axis. Where your graph crosses the y-axis. okay? And how are you gonna find it? Yeah, I'm gonna make x equals 0, okay? So I'll show you a picture of what that looks like, and it may make it a little bit plainer for you, okay? So here's my coordinate plane, and this is my graph, all right? Do you agree that this is my x-intercept? Yes?
Yeah.
Okay, in order for this point to be on the x-axis, which is what makes it an x-intercept, how many do you go up or down? None. That's why the y is 0, okay? So, look, if you looked over here on the y-axis, in order for that thing to be on the y-axis, your x value has to be 0. You can't go left or right any, okay? You can't go left or right any, or you'd be off the y-axis. Okay, so let's say we have a problem like this. Example 5. 5x, I'm going to make my problem really nice and pretty, okay? I mean, it's going to work out nice for us. 5x plus 2y is equal to 10. I'm going to find an x-intercept and a y-intercept. Now listen to me. If this line was such that it never crossed the x-axis, okay, what kind of line would never cross the x-axis?
Horizontal.
Yeah, if you had a horizontal line and I said, what's the y-intercept? Well, you could find that, right? What if I said, what's the x-intercept?
It would be x equals,
Look at it.
None.
None. Could you put 0? No, because then you'd be saying it crossed at 0 and it didn't cross at 0. Okay? So pay attention to what you're doing. All right? You know, how do you write the equation of a horizontal line? Y equals. How do you write the equation of a vertical line? X equals. Okay? You need to know that, guys. That's going to be very helpful to you. Okay, so let's find an x-intercept first. How do you find an x-intercept? What do you do? Yeah, you make y equal to 0, and that will make him be on the x-axis. Okay, so all I'm going to do is I'm going to go to this equation. I'm going to plug 0 in for y, and boom, there it's going to be. So I got 5x plus 2 times 0 equals 10. What is 2 times 0? So what happens to this? Yeah, it's gone. It just goes away. And then you got 5x is equal to 10. What's x? 2. Okay, let's make the y-intercept. If I want to find the y-intercept, what do? Yeah, make x equal to 0. Okay, so I'll go up here to my equation and I'll make x equal to 0. So it's going to say 5 times 0 plus 2y equals 10. What happens to that term? Yeah, 5 times 0 is 0, guys. It goes away. And so I got 2y is equal to 10. What's y? 5. That's it. That's that easy. Now listen to me. I'm okay. If I ask for the x and y intercept, this is good for me. I'm perfectly fine with this. Okay? But if they ask for the point, the coordinates, if the x-intercept is 2, what is the point? What is it? 2, 0. Very good. X is 2. That's the x. Y is 0. We made y 0. That's how we found the 2. All right? If my y-intercept is 5, what's the point?
0.
Very good. Just want to make sure you got that. All right? Now, watch this. I'm going to show you something. It's pretty cool. Okay? I'm going to graph this line really fast. How many points does it take to make a line? 3. It actually only takes 2, right? I asked you to give me 3, okay, because it made your line look better, all right? And so, but look at this. Let's say that I want to find an x-intercept, okay? How do you find an x-intercept? Set y equal to 0. So when you go 2 times 0, that's going to go away, right? And look what you have. 5x equals 10. What's my x-intercept? 2. So on the x-axis, this line line's bumping at 2. Everybody agree? Okay, now I want to find out where does this thing cross the y-axis. How do you find a y-intercept?
So I cover up the 5.
Yeah, you make x equal to 0, which is going to eliminate this term right here. And now I have 2y equals 10. And what is y?
5.
So I go to the y-axis and I go 1, 2, 3, 4, 5. And there's my line. What? Is that so stinking easy or what? Now here's the problem. Y'all, that only works if this thing is in standard form. Otherwise you'd have to manipulate it.
You can put it.
Okay? Could I solve for y and still get the same graph? I would hope so. I would hope so. Okay? I mean, I could solve for y and say my slope is -5 halves. Let's see. 1, 2, 3, 4, 5, and over 2. Yep. And my y-intercept would be 10 divided by 2 is 5. There it is. Okay? So, just 2 different ways to look at it. All right. So, let's talk about our test Friday. Okay? And I'm going to put Friday, Monday. All right? Because we know this is A day and this is B day. All right? This is A day and this is B day. Y'all, and listen, if they do an evacuation and they cancel school on Friday and everything's good and we come back to school on Monday, guess what will happen on Monday? You will have a test on Monday. Does everybody understand?
So they just pick up where they left off?
Yep, they'll just, and normally, I think he'll change that and make that an A day. Okay? Since we missed that day, I think that's probably what he'll do. If not, we'll be backwards, and B day will be taking the test, and A day will be taking the test on Tuesday. All right? If he doesn't change it, but I think he'll change it. But either way, will I text you on Remind and tell you?
Yeah.
Yes, I will. Okay? So there again, you're going to be in trouble if you haven't joined Remind. All right. So I told you to take pictures of the chapter review and the chapter test. Okay? The chapter review and the chapter test. So obviously the review is 1.7. On the chapter test, it's problems 22 through 27. It's 2.1 through 2.3, and that is problems 1 through 11. People, if you're good, work them all one time. I'm asking you to take a picture out of my book where you have the answers. Use the answers to check and see. Don't just go, oh, I don't need to check mine. You better check them, okay? Because I'm going to be checking your test. Anybody got a question? Everybody okay? All right, so now we'll go back and start our 2.4, okay? Now we'll go back and start our 2.4. All right, so 2.4 is, get all my notes straight. 2.4, we are going to write equations of lines. Okay? Write equations of lines. Now, here's what I'm going to say. Most likely, not absolutely positively, but most likely, when you were in Algebra 1, you used this form. What's it called? Slope intercept form. Okay? You used this form to write an equation. They gave you a slope and a point, and you plugged it in for M and X and Y. You solved for B, and then you went back and wrote your equation. Y'all remember that? Mm-hmm. Okay. We're not using that. Okay? Now, I know you're like, what? Why? Why would you do that? Because y'all, I'm going to actually show you an easier way to do it. Okay? But I want to write this down. Do not use. Okay? No credit. You will get no credit if this is the way you get your equation. All right? I'm going to force you to use an upper level math formula. All right? An upper level math formula. Okay, so here is the formula. It is called the point slope formula. Love these math people need to use the point slope formula. A point and a slope, okay? They're not sneaky or anything, so the point slope formula. This is what you have to use. And y'all, what's actually gonna happen is you're gonna put your information out in, and when you collect all your like terms, it's going to give you this equation right here. I'm not gonna have to go back and use my information and plug it back in to get it. It's just gonna give it to me, okay? So, the formula looks like this. Y minus y sub 1 equals m times x minus x sub 1. So that's the formula. I'm going to show you where it comes from. Have you ever seen this formula right here? That's the slope formula, right? If I multiply this side by x sub 2 minus x sub 1, would these two cancel out? If I multiply this whole side, this whole fraction, by x sub 2 minus x sub 1, which is this denominator, wouldn't those cancel out?
Yes.
And you'd be left with y sub 2 minus y sub 1.
That's what you do.
Okay? But what you do to one side,
You did the other.
so this would be m times x sub 2 minus x sub 1. There it is. Okay? So really this is just the slope formula. Okay? It's just written in a different way. Now, it does have a couple of rules. One rule is this. This little y right here and this little x right here. Hands off. No touch. Okay? Those are the x and the y that you will be left with in your equation. Alright? If you have an equation of a line, it has an x and a y in it. That is this x and this y. So obviously my point is going to be x sub 1, y sub 1, and my slope is going to be this m. Alright, are you ready? So, let's do example 2, okay? I'm skipping one, I'm going to do it in a second, okay? So, example 2 says, write the equation of the line that passes through I know that's not how you spell through, but I'm going to. 5, 4, and has a slope of -3. Okay? Write the equation of the line that passes through 5, 4, and has a slope of -3. All right, y'all look. See, they don't pull any punches. I have a point and a slope. Guess what I'm going to use? Point slope formula. Okay? So, here's what you need to do. You're going to have to know this formula. I'm not going to give it to you. All right? So, what I do is every time that I have to use it, I just write it down. Some people will have to write it down 3 times and they'll know it. Some people will have to write it down 6, 7, 8 times and then they'll know it. All right? You know how many times you need to write it down. Y minus y sub 1 equals m times x minus x sub 1. All right, what are we calling this point?
X1.
Yeah, x sub 1 and y sub 1. So this is x sub 1 and this is y sub 1. What's this? That's my m, that's my slope. Okay, so let's plug it all in. So, y, that's my hands off one, minus, what's y sub 1? 4 is equal to m, what's m? -3 times x minus, what's x sub 1? 5. Now, once you plug it in, you have 2 things to do. Distribute and collect. 2 things to do. Distribute and collect. So here's where I'm going to distribute. All right, now I'm thinking about it the first of this year when I told you distributing a negative throughout the parentheses could cause some problems for some people. Okay, and you remember what you made on that test. All right, so y minus 4 equals, what's -3 times x? What's -3 times -5? Okay, now what am I collecting?
415.
Yeah, what are the only like terms you have up there, guys? This 4 and this 15. So what do I need to do?
Add 4.
Add 4. Very good.
Actually, wasn't bad, it turned into this.
Y is equal to negative 3x plus 19. Y'all, that's my answer.
Oh.
Now, that's not bad. Is that bad? No.
It turned into the other one.
Yes, it does. It does turn into that. That's what I said. But on the other one, what you did was you solved for B, and then you had to go back and write your equation. I got my equation. I don't have to go back and write anything.
What about on my test on Friday? Do we need to do it in the school?
None of this is on your test on Friday. Your test on Friday stops on 2.3. This is 2.4. None of it's on there.
I might use it
Okay? All right, so here we go. Let's do this one. I'm going to give you one to do all by yourself. I'm going to tell you that the point it goes through is negative 2, 7, and that my slope is 5. Go. Okay, are you ready? All right, so here's my equation. Y minus y sub 1 is equal to m times x minus x sub 1. Okay, I've labeled my stuff. Okay, and now I'm going to plug it in. Y minus. Now look, when I look up here, what is the first number that I look at? Negative 2. That's going to be a mistake, guys. Okay? Look, this is the way it is, and it is the way it always is. X's go with X's, and Y's go with Y's. Okay? X's go with X's, and Y's go with Y's. If this guy right here is with this X, he is an X. If this guy right here is with a Y, he's a Y. X's go with X's, Y's go with Y's. Birds of a feather flock together. Y'all ever heard of that? Y'all have never heard that saying? I'm like, whoa, yeah. Okay, so have you ever heard your mother saying, no, you don't need to be running around with those people?
Yeah.
Okay, you know why she says that? Because birds of a feather flock together. So if you're running around with a bunch of kids that are up to no good, guess what you're gonna end up being? Up to no good, okay? You're gonna be doing something that you ought not be doing. All right, so that's why she says, no, you're not running around with them. All right, so who's my y sub 1? 7 is equal to, what's m? 5 times x minus negative 2. So minus a negative becomes a what? Very good. All right, now what do I do? Yeah, distribute that 5 right there. So I got y minus 7 is equal to, what do you get here?
5x
Plus,
10.
very good. Now what do?
Subtract 7. I mean, add 7.
Add 7. Be careful because that's going to happen on the test. Somebody's going to go minus 7, and then they're going to get a 3. And it's not going to be right. And you know what? I'm going to show you how to check this thing. And if you had checked it, you would have said, whoa, wait a minute, that's not right. Okay? So, plus 7 and plus 7. This goes away, and y is equal to 5x plus what? 17. All right, so now I'm going to show you how to check it. All right, I'm going to turn my little calculator on, and I'm going to go to y equals, and I'm I'm going to put my equation in there. 5x plus 17. All right, how am I gonna check it?
Put it in
I
the
know the
table.
slope is 5, because it's gotta be 5 in
Put
front
it
of
in
that.
the table.
Oh, the easiest thing would go to a table. How many lines go through this point and have this slope? One. Otherwise, there'd be multiple answers, and there's not. Okay, well, there are multiple answers, but how many are what, right? One. Okay, so there's my equation. I'm gonna go second in table. I'm looking to see if the point -2, 7 is on my table. -2, 7. This has to be right. People, how long did that take me? Not very long. Not very long. Okay? Listen to me. Learn how to use your calculators. Learn how to use your calculators. Now, here's part of the problem. If you don't check your stuff on your worksheet on your calculator, will you remember to check it on the test? No, you won't. Okay? So, make sure you do that. All right, now I'm going to do example 1. You're going to see why I don't like example 1. Like, I just taught you all this stuff, and then the very first example they give me is crazy. All right, so it says write the equation of the line. So I'm going to draw you a picture. All right? Okay, so I'm going to tell you that my line goes through this point right here, and this point right here, which is that guy and that guy's part. Now, do I need to do a bunch of work to write the equation of this line? No. People, there's not any sense doing a bunch of work when we just look at it and write the equation, okay? So what's my Y-intercept? I start with the easiest one. I don't even have to find him. I just look and go, boom, there it is. What's his Y-intercept? -2. Now, I do have to find the slope, okay? So what kind of slope does this line have, positive or negative? Positive. When you read him from left to right, he's going up, so that's a positive slope. Slope is rise over run. Do you agree? So I'm going to start at this point right here, and I'm going to get to this point right here. How many do I have to go up? 3. 1, 2, 3. So my rise is 3. How many do I have to go over? What's your run? 4. So my slope is 3/4. What is my equation? Y is equal to
3/4 x
-2. Very good. Okay? Now, I could graph that, and I could table it and make sure it goes through those 2 points. Is everybody with me? Okay, so what can I do to this problem and make 1/3 of the class miss it? It's a picture. What can I do to the line? Make it go down. As soon as I make a negative slope, I'm gonna drop that sign right there. Okay? Y'all listen to me. What was the very first thing I asked myself when I said, what kind of slope do I have? That's my positive or negative. I'm addressing that. Okay? So look at your line. Y'all, if your line has a positive slope, it best be going up. If your line has a negative slope, then it should be coming down. We read from left to right. So that's the way I'm reading the line. Anybody got a question? Okay, so we got 2 more problems. One I'm going to work with you, and then one I'm going to give you to work all by yourself. Okay? So, just a quick little recap, all right? Parallel slopes. What about them? Okay, so they are the same. They're equal. Everybody agree? All right. What about perpendicular slopes?
They're the opposite reciprocal.
All right, so they are opposite. What does opposite mean? What does opposite mean? Yeah, one's positive and one's negative. Okay, opposite reciprocals. you already know that?
Yes.
Okay, that is gonna be on your test. So this is example 3, and here's what it says. Write an equation of the line that passes through -2, 3, and is A parallel to and B perpendicular to 16x plus 4y equals 4. Write an equation of the line that passes through -2, 3, and is A parallel to and B perpendicular to 16x plus 4y equals 4. All right, so here's my question. How many answers does this thing have? 2 answers. Okay? You're gonna write an equation of a line that's parallel to this line and passes through that point, and perpendicular to this line and passes through that point. All right? So if I need to talk about parallel and perpendicular slopes, what do I need to find on this line? If I want it to be parallel to this line and then perpendicular to this line, what do I need to know about this line? You better know its slope, okay? Parallel slopes will be the same, perpendicular slopes will be opposite reciprocal. So I need to find this guy's slope. 16x plus 4y equals 4. How do you find his slope? Do you just close your eyes and hope it appears? What do? Yeah, you solve for y, people. Put it in slope-intercept form. That's what we've been doing and looking at it and saying, this is the slope and this is the y-intercept. Well, I only care about the slope. All right, so I'm going to take this 16x, move him over here, or subtract 16x from both sides, whatever you want to call it. The x goes first, so negative 16x plus 4. Now what am I going to do? Divide by 4. And y is equal to, what's negative 16 over positive 4? So negative 4x. What's 4 over 4? Plus 1. What's my slope? Negative 4. Okay, so that's the slope I'm going to use. And now I'm going to do my 2 problems. Watch how I'm going to write my 2 problems, okay? So, first of all, the first problem, A, I want it to be parallel to. So, I want a parallel slope. If this is my slope, what's a parallel slope? The same thing, negative 4. Do you remember when we played that game the other day? We made the chart, and I gave you a slope, and I said, what's a parallel slope? What's a perpendicular slope? I was getting you ready for this, okay? What's the point it has to pass through? Negative 2, 3. All right? And then the B part of it is going to be, I want a perpendicular slope. What's the perpendicular slope of this guy going to be? Opposite reciprocal. So what is that? Positive 1, 4. And my point? Negative 2, 3. Now, don't both of these look like the very first problem that we did? I'm given a point and a slope, a point and a slope. I wonder what you're going to use. Probably the point-slope formula. Okay, so I'm going to do this first guy. This is my x sub 1 and my y sub 1. This is my m. X's go with x's, y's go with y's. Y'all listen to me. When I start writing this and I get a little bit in a hurry, y minus. The first thing I look and see is that negative 2. X's do not go with y's, okay? In formulas, x's go with x's and y's go with y's, always. So who goes y minus what? 3 is equal to m, negative 4, times x minus,
Plus
yeah, minus a negative 2 becomes plus 2. Now, distribute and collect. Are you with me? Distribute. So y minus 3 is equal to negative 4x. What's negative 4 times positive 2? Negative 8. And now I collect my like terms. The only like terms that you have are these constant, the plain numbers. How do I get rid of this minus 3? So plus 3 and plus 3. Do y'all know how to talk to yourself in your head without talking out loud? That's what you should be doing when you're working a math problem, especially when you're on a test or something, okay? So, because then when you say something like, how do I get rid of this minus 3? Minus 3, your brain goes, what? What'd you say? And then you go, oh dang, plus 3, okay? When your brain hears you say stupid stuff, it stops and goes, wait a minute, what was that? When your brain hears you go, 2 plus 3 is 5, it's good. But when it hears you go, 2 plus 3 is 6, your brain goes, what? Wait, what? No, 2 times 3 is 6, 2 plus 3 is 5. All right, so these go away. Y is equal to negative 4x. What's a negative 8 and a positive 3? Negative 5. Could I check it? Y'all, you could put this in your equation, in your y equals, and make sure it goes through that point. I know my slope is negative 5. All right, so I'm going to go over here and I'm going to do this guy. Okay, this is my x sub 1, y sub 1. My formula is y minus y sub 1 equals m times x minus x sub 1. Gonna plug them in. Y minus 3 is equal to m, 1/4. X minus a negative 2 becomes a plus 2. Distribute. Y minus 3 is equal to 1/4 x plus, look, we're going to multiply like this. If you can cross cancel, it's harder to cross cancel when you're across things, you know. I'm looking across this x. So top times top, bottom times bottom. 2 times 1 is 2. 4 times 1 is 4. What is 2/4 reduced down to? 1/2. So this is 1/2. Okay, now what do I do? I'm going to add 3 to both sides. Watch what I'm fixing to do. What does 3 have to be in order to have 2 as a denominator? 6? Is 6 over 2 3? So that's the same thing. All right, I'll show you another way to do it if you want me to. These are gone, and y is equal to 1/4 x plus, these are like signs, so I add 7 and take the sign of both. And keep the denominators, don't add the denominators. All right, so if I had just said plus 3 here, I could have said, oh, that's 3 and 1/2. Now, do I want mixed numbers? No, so you got to change that to an improper fraction. What's 2 times 3? 6 plus 1 is?
7.
So you could have done it like that. Or you could have put the 3 over a 1 and gotten a common denominator. Either way. Okay, so I want to show you one trick on your calculator, and then I'm going to give you one to do, okay? And then I'll pass out the worksheets while you're doing it, and then I'll come work it for you. All right, so y equals, I'm going to put this equation in here. I want it to be perpendicular to this one. Do y'all agree? Okay, so I'm going to put him in there. Negative 4x plus 1. Okay? And then I'm going to put this guy in there. 1/4 x plus 7/2. You can use your fraction button if you want to, but I'm not going to. Okay? And I'm going to go, hang on just 1 second. perpendicular. What does perpendicular mean that they meet to form?
90.
Does that look like a 90-degree angle to you?
No.
It doesn't. It doesn't. It's kind of slanted too far this way, right? So, anybody know why?
Because the calculator.
Yeah. Look at the window. Look at the viewing window. See how much wider it is than it is tall? Do you see how far apart these X's are here as opposed to these X's right here? These are a lot farther apart. So I'm going to show you a way to make your calculator show you what it should look like. All right, see zoom? We're on a zoom standard. That's your 10 by 10. He goes to the right 10, up 10, left 10, down 10. All right? But if I put it on a square, number 5, if I go zoom 5, he puts it on a square. See, he puts more tick marks on the x-axis. Now, does that look like a 90? Okay, so he's gonna, when it's on a square graph, then it's gonna show up to be what you think it should be. All right? Okay, so here's the problem that I want you to do. This is example 4. I'm not gonna write all that mess down, okay? I'm just gonna tell you it's gonna go through the point 5, -1, okay? And I want A to be parallel to, and B to be perpendicular to 2x plus 3y equals 9. 2 answers, guys, 2 answers. And while you're doing that, I'm gonna pass out your worksheets. They're going to be due next Thursday, because I'm not gonna do everything on this section. Can I just start doing this one? And that way if you need some help, you can look up here. Is that okay? Okay. Watch what I'm gonna do right here. You see how you had to subtract one right here? Give me a one with a three denominator. What is it? 3/3. All right, anybody got a question? No questions? Okay, so, I'm gonna tell you, I tried to be good, but it didn't work out so great for me. So this is the worksheet that I just gave you. Notice that the first two problems that are on the worksheet, we haven't worked any like this. You can skip them if you want to, okay? We're going to do the very next problem on my working through this section is one like this, okay? But I'm gonna tell you this, you already know how to do this, okay? In order to use the point slope formula, what do I have to have? A slope and a point. People, you got 2 points. I don't care which one you use. Can you find the slope between two of those points? So you find the slope and then you use either one of the points, you'll get the same equation, okay? And then you can work these, write an equation of the line that passes through the given point and is perpendicular. This one's just perpendicular. And then the ones on the back. This one says write an equation and that passes through the given point and is parallel. All right? And this one says write an equation in standard form. So, you can really do, I would leave these word problems alone for right now because I'm going to work one of those. So actually you can work 3 through 12 or you can work 1 through 12, whichever one you want. Okay? Yes.
And this paper is due Thursday?
Next
Yeah, next
Thursday.
Thursday.
Yes, next Thursday. It's like a week, more than a week.